You are drifting in the dark, silent void of space. As the stars fade into the distance, an endless shadow looms ahead. There is no turning back, because you're being pulled toward a black hole, an invisible cliff waiting to collapse beneath you. But what happens if you fall? Will you feel pain? Will you cease to exist? Or could you cross into another universe? Today, we search for that answer. How much do we truly know, and how much is just imagination? If you're ready, our journey into the darkest mystery of the cosmos begins now. This is Cosmoverse, and from here, there's no turning back. Black holes are among the most extreme objects known in the universe. They are so dense that nothing around them, not even light, can escape. But how is this possible? According to Einstein's theory of general relativity, mass bends space-time. While a star like the Sun gently curves this fabric, a black hole collapses into it, distorting it severely. If an object is compressed beyond imagination, the gravitational pull becomes so intense that even light cannot escape. This threshold is called the event horizon. Once it is crossed, nothing can return. The last thing you would see as you approach a black hole is its event horizon. What lies beyond remains unknown. At the centre, there is a point known as the singularity. All the mass is concentrated there with infinite density and zero volume. At this point, the known laws of physics break down. Time loses meaning. The concept of space is fundamentally altered. This is why black holes are not just massive celestial bodies. They represent the limits of scientific understanding. Right now, we are observing a black hole from the outside, but soon we will cross that boundary. As you begin to fall toward a black hole, at first you notice nothing. But this silence is the calm before the storm. As you approach the event horizon, the laws of nature begin to behave strangely. Time, for you, seems to pass normally, but to an outside observer you appear to freeze near the edge. This happens because the immense gravity of the black hole slows down time. It is not science fiction. It is a direct consequence of Einstein's theory of relativity. Around a black hole, time slows so dramatically that while only seconds pass for you, millions of years could pass for the rest of the universe. But what happens to your body is even more terrifying. The gravitational pull is so intense that even between your head and feet, there is a noticeable difference. Your lower body is pulled much more strongly than your upper body. This stretches you into a thin, elongated shape. Scientists call this process spaghettification. Within microseconds, your body would stretch into strands, and your atomic structure would begin to break apart. Nothing we know of can survive such extreme forces. Fortunately, around supermassive black holes, this process happens more slowly. If you're lucky, you might not feel pain as you cross the event horizon. But one thing remains certain: there is no way back. You've crossed the event horizon. There is no turning back. No one outside can ever see you again or hear your voice, because even light is now trapped with you. And you are being pulled into the most mysterious place in the universe, the inside of a black hole. But what lies there? Here, science goes silent, because there is no definite answer. As far as we know, at the centre of a black hole is a point called a singularity. This is where matter becomes infinitely dense, volume shrinks to zero, and space and time lose all meaning. In a way, the singularity is like the universe's software glitch. Physics breaks down here. Einstein's general theory of relativity works, but only up to this point. At the singularity, everything divides by infinity. Yet quantum physics tries to explain nature at the smallest scales. And here, the two great theories, general relativity and quantum mechanics, come into conflict. That's why scientists believe we need new theories to understand what's inside a black hole. One of them is quantum gravity. It's not complete, but it's promising because according to this theory, the singularity might not even exist. Perhaps matter reorganizes itself into a smaller, more exotic state. Some physicists even propose that the event horizon is actually a surface where all information is stored. Everything that falls in, including who you are and what you're made of, could be preserved on the surface in holographic form. This idea is known as the holographic principle. There are other theories too. Could the inside of a black hole be a gateway to another universe? In theory, yes. If the black hole is a wormhole, it could lead to another part of the universe, or even to another universe entirely. But that remains speculation, because once inside, all contact with the outside is lost testing. Any of these ideas on tolls is impossible. For now, we can only observe from the outside. To guess what lies within, we rely on mathematics, quantum theory, and imagination. And among all these ideas, one truth remains clear. The inside of a black hole is still an unsolved mystery, and maybe it will always be. In the 1970s, Stephen Hawking said something truly groundbreaking. Black holes can evaporate. Yes, they don't live forever. Over time, they lose energy and eventually disappear. This process is known as Hawking radiation, but this brought with it a serious problem. If a black hole vanishes, what happens to all the information inside it? One of the most fundamental principles in the universe is this: information cannot be lost. Even if you burn something, the information is still preserved in some form. But when a black hole evaporates, that information seems to vanish completely. This is what we call the black hole information paradox. This paradox puts the two pillars of modern physics at odds. General relativity says the black hole destroys all information. Quantum physics says that's impossible. So, which one is right? We don't have a definitive answer yet, but there are some powerful theories. The holographic principle suggests that the information is stored on the event horizon. The firewall hypothesis proposes that everything falling in gets incinerated at the boundary. Quantum back reaction theories suggest that information could be reconstructed near the black hole's edge. And there's another intriguing idea. Black holes might actually be natural computers processing and storing vast amounts of information, perhaps the most powerful memory banks in the universe, and maybe, someday, the key to understanding its greatest mysteries. In his later work, Hawking leaned toward the idea that information isn't lost, but we still lack solid proof. Maybe, just maybe, black holes won't only unlock the fate of stars, but also the very nature of the universe. And perhaps help us answer the ultimate question: who are we really? Falling into a black hole is, in a way, crossing the boundaries of everything we know. You reach the limits of space, time, even reality itself. At that point, science falls silent, because this is a part of the universe that we simply cannot explain with the rules we know. And maybe that's why black holes don't just terrify us, they captivate us. Instead of running from the unknown, we find ourselves drawn to it. And today, that's exactly what we did together. We looked into the darkest depths of the universe and dared to wonder. This video was created through weeks of research, writing, and visual production. If you found it valuable, please don't forget to like, leave a comment, and subscribe to Cosmoverse. For more content like this, stay with us.